Hello everyone. We just covered examples of runtime errors and semantic errors. Let's now talk about how can we handle these errors in a better way. I want to focus on semantic errors first. Wouldn't it be nicer if you can take semantic errors and convert them into runtime errors? Why would that be the case? That's because runtime errors cause your program to crash, specifically mentioning where exactly the problem is, correct? We just took this scary semantic error, which is difficult to debug, and converted that into a runtime error, which is so much more easier to debug because you're getting exact details about where the problem is. How can we achieve this in Python? The assert statement enables us to do that. The syntax for assert statement is the keyword assert, following which you'll have a Boolean expression. The assertion statements force your program to crash if something doesn't make any sense. The Boolean expression that follows the assert statement can be any Boolean expression that you use with an if condition in Python. Whenever your assert Boolean expression evaluates to true, pretty much nothing will happen and your program will keep running on its merry way. When it evaluates to false, on the other hand, your program is going to crash with an assertion error. Let's talk about the scariest bug that we covered for pizza.py. That was the case when we had a negative diameter. Imagine that I have an assert statement which is going to assert that radius value is greater than 0. Then instead of giving me a slice size which is positive area, the program would just crash, which is so much more meaningful. I want to mention one thing about assert statements though. Assert statements make your program really slow. So sometimes some of the users of your program might just disable all of the asserts in your program. I'm not going to show you how you can do that because I strongly recommend you to use assert statements. Assert statements are really helpful for catching semantic errors, especially for new programmers. Let me give you a few examples of assert statements. The first example here is checking just if the value inside the variable x is greater than 0. The next assert statement is checking if items is not equal to none value. The meaning of the third example depends on whether person is a list or person is a dictionary type. Why is that the case? If person is list, then I'm checking if age is an item inside the person list. If person is a dictionary, I'm checking whether age is a key inside the person dictionary. The last example over here is checking whether the length of the list nums is odd or not. So recall that you can use the modulo operator and you can easily check whether the remainder that comes out of len of nums divided by 2 is 1 or not. If it is 1, then we are happy with that. If the nums list has an even number of items, then we are not happy with that. Let's go back to our pizza.py program and add an assert statement to handle the scariest bug. So recall that when we tried the input of -10 and 8, we got slice size as a positive value, which was 9.81. That's not a correct behavior because negative pizza cannot be sliced into 8 pieces, correct? Let's fix that. I'm going to go into my pizza underscore size function and I'm going to assert that radius should be greater than or equal to 0. Why did I accept equal to 0 as a valid input? That's because when your radius is 0, your total size is 0. And since total size is 0, whatever you multiply that by will just give you a result value of 0. So if your radius is 0, your slice size is also 0. That's a valid input-output combination. So let me go ahead and save this program now and we will try the same input of -10 and 8. This time we are getting an assertion error in line number 4. Line number 4 is the line that I just added over here. Right, let me go back to my slide deck. I want to talk about how to handle runtime errors. What can we do in order to ensure that our program keeps running even if we run into a runtime error? Let's say that I have a function called flaky underscore function. As the name suggests, this particular function is going to throw some sort of error or the other. The way that we can handle that is by using the keywords try and except. So try and except are a pair of blocks, so you cannot use them separately. You should always have an except block for a try block. So whatever you put inside your try block will be subject to evaluation, and when you run into a runtime error in that particular block of code, your except block will get triggered and you'll go ahead and display the print message over here instead of crashing the program. So let me introduce you to one more term here that's called as catching. So whenever we have a try except block and the code inside your try block runs into an error, then we are catching that particular error or exception inside the except block over here. So the term error and exception can be used interchangeably in Python, both mean the same thing. So if your code doesn't have any problem at all, your except block will not run pretty much. So if your try block is successful in running all the lines of code, then your except block is irrelevant. If you run into an error, then your except block will run and you'll display the error. So let's go back to pizza.py one more time and let me show you how you can add try except blocks for this particular example. So you can think of adding one try block around the user input processing set of lines and another around the pizza analysis lines, correct? So let me go ahead and do that. I'm going to tab all this code in and I'm going to say that when I come to this except block, I ran into bad user input. So I'm going to say invalid user input. Please try again. And I'm going to tab the pizza analysis lines in and I'm going to add another try block around it. And I'm going to say that this time we are having pizza analysis error. Alright, let me go ahead and save this program. I'm going to clear the screen and let's start running the program again. Let's go back to some of those runtime errors. Recall that when I say 10 and hello, the program earlier used to crash with value error. Right now it's going to say that I have invalid user input, and notice that the program just keeps running. What if I try out divide by 0 error? What if I try the values, 10 and 0? That's going to give me pizza analysis error. That's because that particular error will happen when we try to actually calculate the slice size, right? So only when we call slice underscore size function, you're going to run into 0 division error. Alright, what would happen if I do Control C now? Unfortunately, I've made the program so rock solid that the program is thinking that Control C is an invalid input and I cannot terminate this particular run. So if I had a while of true loop here instead of saying for I in range, my program will keep running forever and prompting me for the next valid input. So let me show you that. So let me go ahead and comment out this for over here. And let me say while of true, keep doing this. And before I do this, I have a backup window so that I can close this terminal window since I know that it's going to run forever. Now let's try it. I'm going to say 10 comma a. That's a valid thing. What if I say Control C? Notice that it will keep running forever. Alright, I'm going to go ahead and close this window. That's the only way for me to terminate the program now. And let me go back to the previous version. I'll talk about why this is happening shortly, but for now just try to understand that this try except block is so general that we are not able to handle control C separately, which is the kill signal. Let me switch back to my slide deck over here. The next few slides contain screenshots of examples that are provided in the interactive exercises for you. You can either use interactive exercises to go through these examples, or you can download the examples as individual programs from the code link for today's lecture. I'm going to prefer to use the individual programs to go through these examples. That's because Python Tutor does not show you the error stack when you run into an exception. So let me go ahead and open the first program that I want to go through. That's going to be p1.py. And let me also get my terminal window back up here. This particular program has one try except block. It has 5 print function calls within the try block. Notice that the third print function call contains a divide by 0 error. So now if I run this particular program, it's not going to crash, but it's going to just print "that's all folks" after it's done printing the first 2 messages over here. Why is that the case? Line number 3 caused an exception, and that's going to just direct the program to go and execute the except block. So these 2 lines will never get executed because of that. So think about what you want to include as part of the same try block very carefully. What if I had a separate try block for the last 2 print statements here? And let me add an except block there saying the except block will never get executed. What is going to happen now? Now you are going to get these 2 print outputs as well. That's because within the second try block, you did not run into any exceptions. So your corresponding except block will never get executed. Right, let's move on to the next example. The next example is going to show us who exactly handles an exception when an exception happens. I have 3 functions in this example, which are buggy, g, and f. I'm calling f way down here. From inside f, I'm calling g. From inside g, I'm calling buggy. And notice that inside buggy, I have a 0 division error. Do I have a try-catch block around that particular line of code inside buggy? The answer is no, correct? Where am I calling buggy? That's inside the function g. Do I have a try-catch around the invocation? Not really. So where am I calling g? That's inside my function f. Do I have a try except block? Excuse me, I think I've been mentioning try catch block. Sorry about the slip. That's because many programming languages use the terms try and catch together. Python is an exception in that they've used try and except together, but the except block actually catches the exception. My apologies. I should have mentioned try catch block in all the previous mentions. Okay, going back to my original train of thought. I'm calling the function g inside f, and I have a try except block around that, correct? So because of that, this particular 0 division error inside buggy is going to be caught in the except block inside the function f. The way that this works is similar to how reporting hierarchy works in a company. Let's say that a low-level employee makes some mistake, and because of that, something or the other happens on a particular product release. So either the low-level employee can handle his or her own mistake, or they can go to their manager, correct? Their manager can again either handle the issue on his or her own, or they could go to the vice president. Worst case, the vice president, if unable to handle the issue, will just go to the CEO of the company, and CEO is going to be the final person who can potentially handle it, right? So in a similar respect, the person who is going to run this program is going to be the CEO. So if the program itself is not able to catch that particular exception, then the user will have to handle it. And right now we do have a try except block in the function f. So kind of the vice president is able to catch the issue, right, with a similar analogy. So let me go ahead and run p2.py. Notice that we are getting let's call g, and we are getting before buggy, and then you are getting buggy about to fail, and then the next line is the one which causes zero division error. So inside f you're going to get the messages that didn't go well. What if I had a try catch block for buggy here? So what would happen? Sorry, I once again said catch, try except block inside buggy here. um, Buggy says oops, let's just have it that way. So now the error is going to be dealt with inside the buggy function call itself. So kind of the low level employee himself or herself fixing the issue. So you're going to say before buggy and buggy about to fail, and you're getting buggy says oops. And then inside G you're just getting after buggy because you're able to successfully handle the exception inside buggy. And inside F you're going to say G return normally. What if I get rid of this try except block inside buggy and add a try except block inside G over here? So I'm going to say try around buggy, and I'm going to say buggy throwed an exception. Okay, let's go ahead and run the code one more time. Notice that now we are getting after buggy about to fail, we are getting G buggy throwed an exception. And then you will also get G after buggy because you did handle the exception inside the G function call. So your G function call will not cause you to have and deal with another exception. Alright, I'll wrap up the video here. In the next video, we'll talk about specific exceptions instead of having a general except block.